Islas. I'm the manager of sales and marketing. I've been with Surtreat and Coordinated Systems for 4 years now, and I'm going to present to you guys the bridge maintenance programs that we've developed with the New Jersey D.O.T. and some of the developments that we've done with the Pennsylvania Turnpike and with PennDOT. So first, I want to start by telling you who we are, who's Surtreat Solutions. And our company is a technology-based company, and what we do is provide turnkey technical solutions for the life extension of concrete. How we do this with a chemistry-based practical approach. By changing the chemistry of the concrete, we can assure that there's going to be permanent repairs done to the structure. Now, our history starts in 1989 when Surtreat is founded. Surtreat is founded by Anthony Fiasco and Robert Waldy, and they started working on this chemistry-based approach to life extension by developing a holistic solution that will effectively cure the corrosion in the reinforced concrete. So the first project, one of the first projects they did was get the Fermco nuclear plant. This was done in 1994, and after that project, they were able to get their nuclear plant certification. And this was one of the first steps that Surtreat took to get that UFGS spec. Then in 1996, we started working with NASA through the Space Act Agreement, which led to the completion of Launchpad 39A in 1998. And then a few years later, we started working with the Army Corps of Engineers to develop a corrosion inhibitor based on the technology used through that Space Act Agreement with NASA. Same year, we started a 10-year study with NAFEC and in the Okinawa-Kadena Air Force Base. That would be the foundation for us getting into the UFGS specification. In 2010, we started working with the New Jersey D.O.T. to get specified in the Bridge Preventive Maintenance Program, which is what we're going to be discussing today. We also got our international certification in the European Union in 2011. And after those 10 years and the results of that Okinawa 10-year study, we were included in the UFGS as the only system that can meet the surface applied corrosion inhibitor guideline. In 2019, our founder Bob Waldy worked in an ICRI committee, and again, currently we are the only three-part system that can meet that surface applied corrosion inhibitor guideline. So this is our story. Now I'm going to tell you what makes us different. What makes us different is that we, like I said, we're a turnkey solution, chemically based approach to life extension of concrete. So when we have a project, we look at what the problem is. Then based on that problem, we create a diagnosis, which will lead into us developing a solution. So we'll design a solution for that specific problem. Then we manufacture it based on the solution that was designed. We provide all the on-site inspection and all the training necessary so that the solution gets installed properly. We do the testing and the monitoring after it was installed to verify that the performance was met. And all of these steps will lead to the structure being healthy and the concrete being healthy. And this is why we can ensure that the life extension will happen. Now let's talk about what's going on with bridges and infrastructure in general. So it's clear that our infrastructure is in need of rehabilitation. The Federal Highway Administration posts a report annually. The most recent one shows that there's 4,783 structurally deficient structures. Structurally deficient structures are a big pain for the Highway Administration. They estimate that it would cost $16 billion to rehabilitate those 4,783 bridges. This is not even, if they need to replace it, that would be $24 billion. So they need to spend at least 68% of what would cost to replace them just to get them rehabilitated and out of that structurally deficient status. Now, that's only bridges, but it doesn't include the cost of rehabilitating that's just national bridges. That doesn't include the cost of rehabilitating bridges maintained by states and localities. It doesn't include railroads. It doesn't include highways. It doesn't include pipelines. It doesn't include schools. It doesn't include public works. It doesn't include pipes. It doesn't include ports. It doesn't include dams or public buildings or airports. And that is why the American Society of Civil Engineers assigned us a grade of D plus in the nation's overall infrastructure. So we have a long way to go, and it's going to take a lot of money. That same organization, the ASCE, estimates that we need to spend $4.5 trillion just to repair, just to get the infrastructure going. And according to some Harvard professors, economic professors, and actually the former Secretary of the Treasury, Larry Summers, there's an estimation that the state of the infrastructure right now is costing households 50 cents to $1, like a tax per gallon of gasoline, just because of traffic, just because of extra repairs, and it's also costing. According to the ASCE, it's costing us $3,400 per year on auto repairs, extra gasoline, time stuck in traffic. So it's not only hurting, commerce, and it's not only hurting like the cities. It's hurting people, regular people. Now, why is this happening? Now, the main cause of concrete deterioration is corrosion of reinforcing steel. When reinforcing steel starts corroding, what happens is that corrosion starts creating a tensile strength on the rebar and on the concrete. So as the corrosion expands, the concrete gets that expansive tension and starts cracking and delaminating. Now, once that happens, it spreads throughout the rebar. And once concrete has been deteriorated by corrosion, it's going to be more time and more cost to repair. Now, it's important to know that if corrosion is present in concrete, the concrete is compromised. And to this point, what we've been doing, the thing that we've been doing is just patching, right? We see a spot that's corroded, we see some spalling happening, and we just patch it, and we think is repair. But this couldn't be farther from the truth. What's happening is that you're putting a new patch, right, new concrete, which has high pH, which has all that nice reinforcement and that nice state, alongside corroded rebar or bad concrete that's contaminated with chlorides. And what's happening is that corrosion that's on the sides or on different areas, it's migrating back to that patch. So the cycle is repeating. Unless you treat the corrosion that's occurring in the rebar, you're going to have the same problem over and over and over and over again. And this is going to lead to increased costs. One example of this, of replacement versus trying to treat the underlying condition, is the rehabilitation of the Washington Memorial Bridge. So this bridge is steel, is concrete, is everything that we can treat. Now, when a structure like this is left for a long time without proper maintenance, without treating the underlying cause, you get to a point where you have to do a big replacement project, and that costs time, that costs money. In this case, it costs 3 years disruption and a $227 million bill. Now, it was closed. It was only one sidewalk, one lane for traffic for 3 years, disrupting morning commutes, evening commutes. I mean, you guys can see it's a very, very significant project. Now, I'm going to paint a picture. Imagine if we could have done this in 3 months and for a tenth of the cost. And how do we do this? Well, we do this by not having to take down the whole structure and then putting it back on. Because again, we're a surface applied chemistry based approach, not a band-aid. We're not going to take the same amount of time. We're time efficient because it's a migrating technology. We migrate through the concrete all the way to the reinforcement. You don't need heavy equipment, you don't need heavy machinery, so it's cost efficient. You don't need to bring in new concrete, so it's environmentally friendly. And with our products and our technologies, we can do as many as 10 other bridges for the same cost that the Washington Memorial Bridge took, and we can do it at a fraction of time with much less traffic disruption. So let me explain you how this technology works. So our technology, as you guys all know, concrete is very porous, which means that chlorides, airs, acids, water, other chemicals are going to be able to permeate through the gel pores, through the microcracks, all the way to the rebar. They're going to settle in the rebar, and they're going to settle around the rebar, which is going to cause the pH to drop. Once the pH drops, you lose that passivating film on the rebar that's protecting it from corrosion, and it starts to deteriorate. The environment around the rebar starts to deteriorate. The corrosion starts setting up, starts setting place, it starts delaminating that concrete. Eventually, you're going to have those big spalls, those big delaminations. So what we do is we migrate through the concrete, through those same gel pores. The first thing that our product is going to do, or one of our solutions is going to do, is regenerate that passivating film. Make that rust that's there, that's active, and in the cathodic place, in the cathodic stage, make it non-reactive, make it inert. Then our technology is also going to migrate through the gel pores, and it's going to start binding with the free calcium. That's going to displace any contaminants and any acids, any waters, any chlorides that are there. It's also going to turn those chlorides into an inert state so that they can't be, they're not water soluble anymore. So once you do that, you basically prevent that process of the pH dropping. You prevent that from happening again. And because it's a chemical approach, it doesn't need to be reapplied. Once that chemical process happens, it's done. So our solution is surface applied, it's easy to apply, it migrates, and it's permanent. Now, why is this important? What's important to extend the service life of structures? Well, if we have a structure, we have a current structure that we're working with. If we take it down and rebuild it, the same thing is going to happen again. If you don't protect that structure, same thing. But what if I tell you that we can protect the current structure and we can make the structure that you have right now better? So you don't need to do demolition. What if I tell you that not having to rebuild the structure will help you reduce the contribution of CO2 emissions, because, as you know, concrete is the third largest polluter right now in China. It's responsible for 8% of total global CO2 emissions. So by not needing new concrete, you will be able to reduce your CO2 emissions. And you will also help reduce the 600 million tons of construction and demolition debris that are produced annually by concrete. You will also increase the utility of your public funds because you'll be able to do more bridges faster. You will reduce traffic and disturbances because our system is non-invasive, and you will save on cost compared to traditional methods. So an example of this cost saving, I want to take you back to this study that the US D.O.T did in 2017, where they took, they studied the difference between replacing and repairing bridges. They took basically all the bridges that are in the NHS, which is a national highway system, and the non-NHS system that are structurally deficient. That means that they are in need of repair within the next year or two. And they found that overall, repairing is 32% cheaper than replacing, obviously, right? But what if I tell you that there is even a cheaper way to extend the service life indefinitely? So those repairs will be effective. You will be indeed repairing the structure, and you can make it even cheaper than what they estimated. So you can even bring a higher benefit to the taxpayer. These are just some case studies that where the alternative what the engineer recommended would cost and what it actually cost us to repair that structure. It goes from 60 to 80% savings, which is significant when you think about it in public funds. And these are some of the people that or some of the customers that we're working with today. We have from the Department of Defense, the Department of Energy, NASA, NAFAC, through the UFGS. We're also able to work with GSA, with Homeland Security, with Department of Veteran Affairs. We also work with private engineering firms like Loureiro and Jacobs, RMF. And we're also specified in New Jersey D.O.T, Colorado D.O.T, Oklahoma Department of Transportation, Virginia D.O.T. We are working and we have worked with Massport on a few projects. We work with organizations like the University of Maryland for their utility tunnels, and we also we have partnerships with FRP companies like Five. So let me walk you through that UFGS specifications that allows us to work with Department of Defense. So that was the 10-year study that I mentioned at the intro of our presentation. This basically, after 10 years, they demonstrated that there was an average reduction in corrosion rate by 80% that has realized. But what this means, it doesn't mean that we reduce the corrosion rate by 80%. It means basically that we reverted the current process of corrosion. And basically at the point where we were able to get this study after the 10 years, it proved that there was no corrosion occurring. So that's what was able to get us into that UFGS specification, and that's why we're the only system that meets it. And at the end, we're going to discuss some of the projects that we've been doing with that UFGS. This is also our ICRI guideline. This is a very important as you are looking into this bridge deck and maintenance programs, because this is the only true way that you can, even before you do any repair, before you do your concrete repair, before you do FRP, before you put pavement again, you need to make sure that the structure is clean, that the structure is healthy, and that the structure is not going to continue to deteriorate. So this guideline is going to be critical for people that are specifying our products, because it'll tell them exactly what they need to do, how they need to do it, and the performance that you're required. You'll see that our solutions are the only ones that can meet those performance requirements. So after this introduction of the problem, the current state, let me walk you through the New Jersey D.O.T maintenance program, which is one of our success stories in this in this bridge maintenance programs. So New Jersey D.O.T, they have 39,000 miles of public roadways, 3,000 miles of state and U.S. highways. They have 500 miles of interstate highways. They have so many structures, and they started this maintenance program when they realized that they needed to develop something that was going to be cost effective in the future, and not necessarily going to break the bank every time something happens. So it was created in 2007 and using state funds. And in 2009, the FHWA took notice of the efforts and expanded it to be a federally funded project. Now, what they do is that they repair bridges that within the National Bridge Inventory deck, the superstructure and substructure that have a rating of 5 or higher on a scale of 0 to 9. So things that need repair like within the next 4 years. And this, because of their involvement in the FHWA or the federal, because it's federal funded, this scope is allowable work outlined in a joint in New Jersey D.O.T and FHWA guideline document. So the work that we've done preventing corrosion has been significant. I mean, we've been able to reduce the work orders, which is patching and potholes and all that, from 20,300 to 5,100. We've done over 400 structures, which is over 4 million square feet. And for those of you that were wondering how easy it was to install, this is how easy it is. All you need to do is make sure that you got the right square footage so that you get the right deal. And it takes one lane, the other lane can be open. Simple as that. I think you'll see that some cars are passing by while you're effectively extending the life of your structure. Now, I'll tell you a little bit more of the story of this New Jersey D.O.T. So our partnership with New Jersey started in 2003. In 2003, when Surtreat when Surtreat began testing a testing program for 4 bridges that were to receive deck treatment. We started with non-destructive core testing before and after Surtreat, and then we sent those results to the University of Florida, where they analyzed the results before and after. There we left control areas that were untreated in the deck, just to be able to measure the change. And the test results indicated that the application of Surtreat had a notable positive effect on the properties of the concrete deck. They increased the strength, it decreased the permeability, and decreased the corrosion rate of the structure. These 3 factors are what allow us to say that we effectively extend the service life and that our products are permanent. Once you change the chemistry of the concrete, there's no coming back. You can't damage that. The porosity is close, and no chlorides are going to come in. Because no chlorides can come in, the corrosion rate can't revert again because you already have that passive state on the rebar. So there's effectively no way of returning to what was occurring in the past. Now, a little bit of same story with the Turnpike. We're a Pennsylvania company, and we have history with the Turnpike and with PennDOT. I'll show you a couple cases from the Turnpike and a case from PennDOT. But this bridge was done as a demonstration just to show the impact of what Surtreat could do. As you can see, I like this picture a lot in the bottom because we started installing the Surtreat, which again reduces the porosity, reduces the water permeability, and then it started raining, so we had to stop. Then the next morning we came back, and as you can see, the area that was treated Surtreat is virtually dry. No water was able to penetrate, whereas the areas that were not obviously have a big change in color. So increasing compressive strength, 69%, reducing water permeability, 96%. That's porosity. That's the things that allow the chlorides to come in and damage the concrete. And increase the pH from 8.9, which is a corrosion active state, to a 10.11, which is a corrosion passive state. So basically at that point, rebar cannot corrode. Then this is a more recent case study. This was last year, where the PennDOT had a bridge that needed FRP and FRP reinforcement. For those of you who don't know what that is, FRP reinforcement is a surface applied, going on with the theme, a surface applied structural reinforcement that adds capacity to any structure. So if you need to increase the loading capacity, you can apply FRP, but FRP has certain parameters. You cannot install FRP in a structure that has under 100 psi pull-up strength. So you need to ensure that whatever is happening underneath the FRP, the structure that you're repairing with FRP, it doesn't have corrosion, because if it has corrosion, you won't be able to it'll still deteriorate. It'll still it'll pop the corrosion, the spalling due to corrosion will pop out the FRP. So we needed to treat that. We applied there was 2 different beams. We applied our Surtreat technology, our circle primer, and after the application, we see increases of 245, 300, 250 psi, which then in fact allow the structure to be repaired with FRP. So there are many benefits to treating the structure. And like I said, if you have a healthy structure, any repair that you do will result in a good repair. You have to make sure that the structure is healthy before you even think of repairing it. Now, this is, I'm not going to go much into details, but this is another project that we did on the Pennsylvania Turnpike. Basically, they were looking for a way to stop the water infiltration, to stop the corrosion that was occurring, because there was a lot of salt that was thrown in, the structure was cracking. So what we came up with is a solution that's a latex modified cement repair, which is basically gives us that corrosion protection, and it also gives us the benefit of having like a structural finish at a fraction of the cost. We did the abutment walls, we did the piers, and this is an image of how it looks. And this structure at this point, it not only looks like it was repaired with normal concrete, but it has that added benefit of the Surtreat, which will stop the corrosion. We have also another bridge in Texas where we were able to decrease the water permeation to basically a point where it was completely sealed. We also reverted the corrosion that was occurring. So you had a corrosion active state on the rebar, and then with our products, we're able to revert it to where there's no corrosion occurring. We also have worked with the New Jersey Highway Authority. This is another project that we did where, again, we increased the pH to a point where it's corrosion passive. So there's no corrosion that can occur. And I also want to show you guys a few projects that are not highway related, but are also very important because we talked about them and they're part of our history. NASA, I think, is a turning point for us. As you know, when you've seen the pictures of rockets, when they go up, they shoot down the thrust, right? All that energy is driving things in the concrete, and then to cool it down, you have water that gets thrown in and just helps drive that. So NASA and those contaminants. So NASA was noticing that their concrete structures were deteriorating faster than they expected. So they started looking for a way to make sure that the corrosion was not going to affect the structure. And this is how Surtreat started. So as you can see, we reverted the corrosion process, and this is kind of how this is the inception of Surtreat. Most recently, we also have worked at a pier. This was new concrete that was not cured correctly. There were some chlorides coming in. This was for Massport. We treated, as you can see, there's some micro cracks that were allowing the water and contaminants to be driven down. So we treated the structure back in 2019, and there has been no complaints. In fact, we're still working with Massport to get this into more structures. This is a Cadena Air Force Base project. This is part of our UFGS. Like I explained, the corrosion was reverted. This was a 10-year study. So testing was done periodically to see the increase. And what showed us is that as the product keeps migrating and keeps reacting with the cement, the increase is better and better, and the performance of the product is better and better. So that tells us that it is, in fact, a permanent solution. We've worked with the Pentagon, similar to the Circle Primer for PennDOT. This is sort of the same solution, but for waterproofing membrane. We've returned to Okinawa last year and this year and the next year for a multi-phase project that will treat ammunition bunkers with the same solution. We've worked with Loureiro to get into with the same UFGS specification to get us a waterproofing corrosion inhibitor. And what I like about this specification is that they don't allow any product substitutions because, again, our products have been tested for 10 years. So why change something that works great, right? And like this, I can show you many, many studies. I mean, we have worked nationally, internationally on bridges, on military bases, on airports, dams, you name it. So I can, if any of you need a report, a specific report, or have a specific case, please contact us, and we'll make sure to give you the information that you require. And to close up, I just want to kind of highlight the benefits of our solutions. We're an enduring solution. It's a permanent solution. It's not gonna deteriorate. You don't have to reapply. We're changing the chemistry of the concrete. It's effective because it treats the underlying condition that the structure has, the deterioration of the concrete and the reinforcement. It will give you a healthy structure. It's efficient. It doesn't take a lot of time. It doesn't take a lot of equipment, a lot of money. All you need to do is a surface applied application. It's environmentally friendly. It's a water-based solution. You reduce the amount of concrete, new concrete that you're generating, which will reduce the CO2 emissions of concrete. And it's economical. It's compared to the cost. I mean, we've shown throughout this presentation, repairing saves 32%. And then if you add that, Surtreat saves 60 to 80% of the cost of traditional repairs. So this is who we are, the 5Es. So please, if you have any questions, if you have any comments, let us know. Please go to our website, surtreat.com, and shoot us an email at info@surtreat.com. Thank you.